Thank you for joining us today. We're really excited to talk with you about bringing your Kubernetes clusters to Google Cloud. But before we dive in, we want to introduce ourselves. My name is Chakeres, and I'm an engineering manager in GKE, and our team is making it possible for you to manage and monitor all of your Kubernetes clusters, whether they're in the cloud or on-premise. I've been working with Kubernetes for several years, and I've lived through different tech transitions, for example, from bare metal to containers and monoliths to microservices. And I've seen the velocity that these modern technologies provide by allowing you to concentrate and focus on your core business. Matt?
My name is Matthew Delio. I'm a product manager on GKE. I've been on the team for about 2.5 years now. And for the past year, I've been focused on providing a fantastic multi-cluster experience for Anthos customers. I'm excited to be on stage to talk to you about our latest offering, and I'll hand it back to Ian to get us started.
All right, before proceeding, I do need to reiterate this safe harbor statement. We are talking about many forward-looking products of varying maturities, and the products and the timelines are subject to change. Now that I've told you about the safe harbor, we can dig into the talk about bringing your Kubernetes clusters to Google Cloud. GKE is already our favorite place for Kubernetes, and I'm sure you've heard about the announcements related to Anthos and GKE on-prem and how these are connected to Google. We understand that you, our customers, have chosen Kubernetes to enable you to move fast. We understand that you have to operate in many different environments, and we want to meet you wherever you are. Anthos was built to help you quickly develop, manage, and operate your business. And today, we're excited to talk about connecting all your Kubernetes clusters, no matter where they are. Matt?
Great. Thanks, Ian. So we're going to start out today by exploring the problem space a bit more. We're going to see what challenges you're facing and show how Anthos can help address those challenges. The second thing we'll do is Ian will give a technology deep dive, so you can learn a little bit more about the product. And we'll finally end with some demos so you can have a more concrete view of what we're doing. To get started, let's focus on the first section, though, which is the problem statements. So when we talk to you, we often hear a very similar message. In order to be successful, your business and IT organization needs to be able to adapt to rapid changes in consumer demand. And you also have to create a competitive advantage. We know you need to do this simultaneously in multiple clouds and on premises, while also reducing risk and cost. This is a tough challenge, but it's not impossible. Microservices and containers can help make your developers and operators more productive, and Kubernetes in combination with Anthos can help you run more efficiently in these multiple environments. First, let's dive in to find out how microservices can help you achieve better velocity. In the VM and bare metal era, applications were built as monoliths. They had very little component modularity, and it was very difficult to actually build and release. So this totally made sense given the tools and solutions that were available. However, it really wasn't the best way to build and release software services. As you know, monoliths tend to be built and qualified as one unit, and so a bug in one part of the code can hold up an entire release. And as a result, teams tend to move more slowly when they're building monoliths. Microservices help fix this issue. They allow you to break apart your services to introduce much more modularity. Teams can then operate independently from one another, releasing their pieces at their own pace, and they really only need to focus on making sure that their APIs remain stable. However, to be effective, microservices also require a different packaging and runtime mechanism, hence containers. With containers, you can put all your microservices and all the dependencies into small immutable images. These allow you to reuse the same binaries when developing, testing, and productionizing your workloads. This makes it easier and faster to develop and debug. And as a result, developers and operators can focus more on development instead of managing and patching infrastructure. OK, so we've gone over microservices and containers, and this finally brings us to Kubernetes. Kubernetes does a lot of things to help running containers and microservices efficient. But today we'll focus on one key aspect needed to move quickly in multiple environments. And Kubernetes provides an abstraction for the underlying infrastructure. And this is super important. With Kubernetes, you can learn one technology, one set of APIs, and apply it anywhere that Kubernetes runs. You can develop common tooling that works across all environments, and this will really give you the ability to run your applications efficiently in cloud and on-premises. Next, we'll spend a few minutes discussing why you'd want to run in multiple environments in the first place. This mostly falls into 4 use cases: modernizing in place, offering choice for both the organization and the developers within your organization, tackling local compute needs, and finally, technical needs. The first use case, modernizing in place, usually has 2 facets to it. The first one is data gravity. Your data tends to be collected and placed in one location or in a few locations. And it's very costly and time-consuming to move it around to wherever your compute happens to be at the time. And also legacy services play into this as well. Like, for example, mainframes and database and other services that really just cannot easily be moved to cloud. They're sort of just stuck where they are, and you have to live with them. But you'd still like to adopt modern development and operating practices around those pieces that cannot move to cloud. And you'd like to use the same tooling in cloud and on-premises. And so you turn to Kubernetes to do exactly this. Now you can modernize your applications at your own pace and move to cloud if or when it makes sense. The second use case we find often is choice. And like I said, it has 2 facets. One is developer choice. You tell us all the time that each cloud has its own set of managed services that really aren't found anywhere else. An example of this is BigQuery. It's only available in GCP. And some teams within your organization might really want to use this service. But there might be another team in another part of your organization, or even on the same team, that wants to use another cloud provider's product. And so it's really important to give your teams the choice so they can choose the tools that are most suited for the project that they're working on. Another one you've told us is really important to you is avoiding vendor lock-in. You want to ensure that you're not tied to any single cloud provider, and that means that you have to choose a software stack that allows your applications to be portable. The third main use case is local compute needs. And this often comes up in kind of industry verticals. So we've seen it in industrial and retail, for one. In industrial, it tends to be manufacturing, warehouse automation, natural resource exploration, and many others that I haven't listed here, where it's critical to provide compute near to where it's being consumed. In the retail side, it's also somewhat of a similar need. In brick and mortar stores, you need to have local compute for enhancing customer experience use cases. Examples of this are digital signage, point-of-sale systems, credit card processing, and other emerging use cases, again, that I have not listed here. Here, it's also critical to provide compute near where it's being consumed. Sometimes we see it for availability, but there's also many other reasons as well. It's a bit different from the industrial use case because there's likely more locations. It's brick and mortar, so there's lots of retail stores potentially. And each location likely has a smaller footprint. Hardware looks a bit less like what you'd find in a traditional data center. It's usually lighter weight. And remote management in the retail environment is super important because your IT org isn't often nearby. This brings us to the fourth use case, which is around technical needs. So you probably leverage several environments because you need to meet some sort of technical or business need for your services that you're offering to your own customers. To do that, you need to run in multiple environments to provide low latency round-trip times for your services, potentially. Or maybe you have a high bandwidth application that really needs to be very close to where the data is being consumed. Or maybe you have to provide resilience against outages, either in your clusters, your whatever environment is, or the entire cloud. OK, so we went over how microservices, containers, and Kubernetes can help improve velocity. We saw the reasons why you'd want to run workloads anywhere. But how do you actually work effectively and efficiently in all of these environments? And that's why we built Anthos. At a high level, it's a software stack that uses Kubernetes as a foundation with services built on top of it. This makes managing hybrid and multi-cloud environments easy. At its core, Anthos is made up of 3 main components: a set of cloud services provided by Google, a marketplace of third-party solutions, and a control plane for managing these various environments. On the compute side, which is the part at the bottom of the slide here, we've got 3 environments listed as examples. We've got GCP, on-prem, and then other cloud providers. And the idea behind this is this stack allows you to write once, deploy in any cloud, achieve developer and operator consistency across environments, increase workload mobility, modernize your applications in place or wherever they need to be modernized, and accelerate developer velocity as a whole. For this talk, we're going to focus on this box I've got here in red. It's really the connection between the clusters running in each one of these environments, specifically the Kubernetes clusters. And we're going to focus on observing and managing workloads across those clusters. If you're an existing Anthos customer using GK on-prem, you're actually familiar with this technology already. It's what we're using to connect GK on-prem clusters to the cloud. What we're announcing today is an alpha feature for Anthos that allows you to view and manipulate your Kubernetes workloads using the GCP Cloud Console in any Kubernetes cluster. I'll now hand it over to Ian, who will go through some of the technology we've developed.
Thanks, Matt. Thanks for making that announcement. And I'm going to tell you a bit about the technology behind this, and then we're going to be able to get to a bunch of different demos. So I'm going to start by talking about the Cloud Console, and then talk about the technology that actually connects clusters to Google. The Google Cloud Console is a single pane of glass for all your GKE clusters, and we're extending it to support Kubernetes clusters anywhere. In GKE on-prem, all these clusters show up right alongside your existing GKE on-cloud clusters. This single pane of glass allows you to manage and monitor your workloads in the same way, no matter where they are. You can dig into each of the different clusters and cluster resources, for example, the version of Kubernetes and the nodes that make up that particular cluster. You can view and inspect the different workloads, for example, what is deployed within each of the different clusters, the version of the different pods and containers, as well as the status and the health of the different Kubernetes objects. The GKE UI also provides additional context and surfaces relevant information. For example, if you're debugging and you have trouble scheduling workloads, or workloads are pending, or container images that can't be pulled, this information is brought to the forefront by the UI. If you have sufficient permissions, you can also manipulate resources directly from the UI. For example, scaling up a deployment when you expect to have more traffic or you need higher redundancy. The Cloud Console provides this consistent UI for your admins and your developers across clouds and across clusters. So now that I've told you about the UI, I'm going to tell you about connecting your clusters to Google. To register your clusters with Google, you install an agent inside your Kubernetes cluster. When you're using GKE on-prem, this registration occurs automatically when you create the cluster. If we look at the image on the right, in the bottom half, this is actually your infrastructure with your Kubernetes clusters with Kubernetes API servers in them. The top half, this is Google. So you run this agent within your cluster, and it reaches out to Google. The cluster and the API server do not need to have any public IPs or be publicly accessible. So you can keep your clusters private. The agent itself can traverse VPNs, NATs, firewalls, and proxies. And if for any reason the agent gets disconnected, it will periodically attempt to reconnect to Google. So now that I've told you about connecting to Google, I'm going to tell you about how we secure those communications. So the connection between the agent and Google is authenticated and authorized using a GCP Service Account. Looking at the diagram on the right, within the cluster near the agent, you have that key and the little cloud icon. This actually is the credentials for a service account, and it unlocks the service on the Google side, the lock above it. The service account is bound with specific permissions that allow the agent to connect to your project at Google. After this connection is established, it is secured using TLS and SSL. TLS provides the integrity and the encryption of all the communications between the agent that is running in your cluster and Google. This service also supports advanced security features like VPC service controls via cloud interconnects that will allow you to restrict from where your agents connect to Google. And now that we've got a cluster connected, we can talk about logging in. So when you visit a cluster in the Cloud Console, you'll be prompted to log into those clusters. Each user logs into a cluster individually because the login is specific to that user. So similar to the prior diagram, we have a key, and that is actually at a laptop at the Cloud Console, and that is a Kubernetes credentials for the cluster. It unlocks capabilities on the API server within the cluster to which is connected. So when you log in, you are logging in as you. And the permissions that you have within that cluster are based upon your role-based access controls, or RBAC. And the key is your credentials. So you, when you log in, you are actually interacting with the cluster, and you are authenticated as you, and you are authorized to perform different actions as you on the cluster itself. One of the benefits of this mode is that all of the interactions that you have with the Kubernetes API server are audit logged at that Kubernetes API server. The other thing is that administrators can control what permissions you are authorized to do. The Cloud Console supports multiple different ways to log into clusters. For example, using basic authentication like a username and password, as well as Kubernetes Service Account tokens. We'll also be offering OIDC and supporting Active Directory for login soon. Administrators can use RBAC permissions to scope what users can perform. At a minimum, to log in, users are required to have view and node reader permissions, and this is simply so you can see anything about the cluster and the basics of that cluster. If you are granted higher permissions, you can see more and you can do more. For example, if you're granted cluster admin permissions, you can view and manipulate most of the resources within the Kubernetes cluster. And now that I've told you about securely logging into your clusters and interacting with them, I'm sure you've got some other questions. So the first question is probably going to be, can I connect my Kubernetes clusters? So there are a few things that you'll need before you can connect your clusters to Google. One, you'll need to contact your sales representative to get involved in the alpha. On the other hand, if you are an Anthos or GKE on-prem customer, you'll already be using these capabilities. You will need to have a Google account so that you can log in. You will also need your clusters to have connectivity back to Google so that the agents can form the connection. Once your cluster is connected, you'll need credentials to log into that cluster to be able to interact with it. You can connect clusters with a variety of different Kubernetes versions. Presently, we support Kubernetes 1.10, 1.11, 1.12, and 1.13. These are the same versions of Kubernetes that are supported on GKE, and the Cloud Console supports these. Now, you may be wondering, what types of clusters can I connect? You can connect GKE clusters from other projects. Your GKE on-prem clusters are automatically connected. And we've connected a wide variety of different clusters running both on cloud and on-premise. For example, on AWS, Azure Kubernetes Engine, and even OpenShift. And now that I've told you about the different types of clusters that you can connect, I'm going to hand it back to Matt.
All right, thanks, Ian. So we've got 3 demos for you today. I'm going to do the first demo, and then I'll hand it over to you to do the second, and I'll come back for the third demo. The first demo we're going to do, whoops, wrong way. First demo we're going to do is connecting a cluster and logging into it. So we're going to show you how you would actually go about deploying the Connect agent, registering the cluster, and then logging into the cluster. We'll also do a brief tour, both at the beginning and at the end, on what you get with the UI, and then Ian will spend a lot more time on the UI piece again. So if you wouldn't mind, can you switch us over to the demo screen? Great, thank you. So here's my Cloud Console. I went in. This is the Kubernetes Engine page that you normally get. In here, I've got 3 clusters already here. If you look at them a little carefully, you'll see that they're actually not normal. So I've got an AKS cluster here. This is an AKS cluster running on Azure. This is a GKE cluster, a regular GKE cluster. And I've also got a GKE on-prem cluster that I set up in San Jose. So the reason it's not normal is this is usually filled with GKE clusters. Now I've got, like I said today, we're announcing that you can register these other clusters. And so you can see all 3 of these in one spot. So if we click in on the GKE on-prem cluster, you'll see that I can get some very basic information about it. I can find out what version of Kubernetes it's running. This one happens to be running 1.11. I can see the number of nodes and the total number of cores in memory. If I want to dig down even further, I can see what storage has been provisioned to it, so I can see what PVC is there. I can see the provider of the PVC, so this is using vSphere. And I can also see the storage classes that exist inside this cluster. If I click on nodes, I can see even more information. It'll break down those 3 nodes and tell me information about the amount of memory, CPU, and storage that's available. And I can click on any one of these nodes and actually see the running workloads inside them. So as you can see, I'm running Prometheus and a few other things on this cluster. I can also see some high-level summaries around the different resources I'm using, as well as conditions like disk pressure, memory pressure, any other types of issues that we're seeing. If I go back to the cluster list page, I had to zoom in for the purposes of the demo just so you could see everything on the screen, but there's a new button here that says Register Cluster. And if I were to click on that, you'll get brought to the screen here, which is a guide. It's a multi-step process to help get installed, but you'll see how quick the steps are. So the first step is just to configure the Connect agent, the thing that we're going to install inside the cluster. It turns out I've got a cluster already ready. It's a COPS cluster that I built on AWS. And so I'm going to go ahead and name it. I'll call it COPS on AWS. And the next thing we need is this service account key. And as Ian mentioned, we need to have a service account so that we can authenticate the Connect agent that's running in your cluster back to Google. So when it connects, it'll actually show up with a Google identity that it recognizes, and it'll authorize it to work. To do that, let's switch over. So you can see on my screen here, I've got 2 text files. And we'll get to the first one actually in a minute, but the second one here, the GCP Service Account, is that service account. So I'm going to copy that into my paste buff, and then we'll go ahead and paste that in here. If we had an egress proxy, we could also configure that, but we don't in this environment, so I'll just hit continue. And then I'm presented with a thing to download. So I'll go ahead and download this manifest file, and we'll go ahead and copy the command that we're going to run. When we hit enter, it'll actually go and install the manifest, the agent manifest inside the cluster. You'll see it creates a namespace for it itself, a few service accounts and role bindings, as well as the secret. So that GCP service account ends up being put into the secret here. And finally, there's a deployment that actually has the agent that's running. When it's done connecting, you'll see there's a checkbox on the screen. That means it's connected back to Google. It's authenticated itself. And we hit continue. Here we're going to set some basic metadata about the cluster. So when I created this, I created it in US West 1A on Amazon, and provider is AWS. We can also set some other metadata that we might want to use later for maybe a CI/CD pipeline that can actually look at the key value pairs that we set on the cluster. So let's call this one environment production. And we click register, and we're going to be brought back to the cluster list page. And you'll see that we have our 4 clusters now. The last one is the new cluster we just registered. And you'll see that also we need to log in. So anybody who goes to their Pantheon or their cloud console right now would get a similar view. And they would also have to log in. So when I log in, I'm going to log in as just myself. And turns out that I am the admin for this cluster. So I'm going to copy the admin token into there. And then we'll go ahead and just paste that right in here and click login. As soon as I'm done logging in, I'm again brought back to the page, and you can see that now I have more information about the cluster. If we wanted to, we could go in and we could click on this and do the same kind of exercise we just did. Yeah, that's it for the first demo. If we go back to the slides real quick. So as you saw, we were able to deploy the Connect agent, register the cluster, and then log into it. And then we were able to browse around in the UI. I'll now hand it over to Ian, who will do the next set of things.
Thanks, Matt.
Sure.
Demo gods are happy. This
yes.
is good.
Yeah.
All right, so Matt talked about connecting a cluster. I'm actually going to talk about monitoring generally, debugging some problems, and performing some updates. So the first thing I'm going to do is look at the workloads and actually look at the contextual and actual information that's surfaced through the UI. There is going to be a problem, and so we're going to kind of dig into that problem and see how we can reconcile that problem or resolve that problem. We'll make some changes and actually solve the problem. Then we're going to scale up a deployment. So we know that we're going to need some redundancy or we're expecting some more traffic. So we'll go ahead and we'll scale up an application. And then finally, we've got a new version of our software. That same software we've scaled up. And now we're going to roll out an update. And we're going to roll out that update incrementally using a rolling update that Kubernetes provides. Please switch over to the demo laptop. Okay, so Matt was in the cluster page, and now I'm going to go over to the workloads page.
We think it's the Wi-Fi, or the network connection. So it should come up in a second. Oh, there it goes.
All right, great. So in the workloads page, we see a bunch of different Kubernetes objects. We get their names. We get green checkboxes for the status. And then we also get the type and the pods, the namespace, and the cluster that they're running in. And we can see the connect agents from each of the different clusters. And we can actually see there's something going on here with this one. We don't get that checkbox. So I'm going to go ahead and I'm going to click into that to see what's going on. All right, so we can see right away that there is an error here. But before we dive into the error and really troubleshoot it, I do want to look at the page a little bit. So again, we have information about the cluster, the namespace. We have labels that we've set. We can see the replicas here and one unavailable, 0 available. That doesn't look quite right. We have the deployment information, the name and the status. We can see that big red exclamation point, and information about the container image that is contained within this deployment. And actually, I'm going to go ahead. We'll click in here on show details. So what you can see is we have an application here. It's from Kelsey. And there has been a typo by the developer in terms of what version they should deploy. So it's pretty clear to me. I think we can debug in terms of what we need to do to resolve this problem. So actually, I'm going to click over into the YAML. And here you can see the deployment, and you can see all of that information in the YAML manifest, both in terms of the metadata and the spec, and even the status down here. And we can see here the image with that typo. So let's go ahead. We're going to go ahead and click Edit. And now we can actually go in and directly edit this particular image and application. And I'll scroll to the bottom, and I'm going to hit Save. Now what's happening is that the UI is actually deploying the manifest with the updated image tag. And you can see that it's saying that the pods are pending as it's making that particular change. We'll just refresh.
This wasn't happening earlier, I promise you. Okay.
All right. So now we can see we've got the green checkbox on hello. And also we can see down here the image tag version. And we also see the number of replicas one is available. And we can also actually look at the different pods that are being managed by this deployment. So let's just click in on that particular pod. We can see even more information. And again, look into the different parts of it, and let's go ahead. We'll look in on the logs on this particular pod. And so we got what we wanted here. We see that the server started up, the health service, as well as the HTTP service that is supporting it. So this looks great. Now we have debugged our problem. We've rolled out a change to the application. We've got a green checkbox. But now we know we only have one of these. So let's go ahead and scale this up so we get 3 replicas of this particular workload. So we're going to go to the Actions tab here, and we're going to hit Scale. And so instead of 1, we're just going to change this to 3. And when I click this button, it's going to declare, I want 3. And what we expect Kubernetes to do is to actually spin up 2 more pods like the first one. And so what we see immediately is that We now want 3. We only have 1. 2 are not yet up. So let's hit refresh and let's see. Now we have the 3. Let's see. And we have the green checkbox on the status. We have 3 updated, 3 ready, 3 available. All of them are version 1.0. And we can actually click into those different pods again. And if we want to look at the logs of a different pod, we see those same status messages that are indicating that everything is healthy. So this is great. Now our application has 3 replicas running, so we can tolerate an error that would take down one of them. But now our developers have a new version. So now it's time we want to roll out a new change. So I'm going to go back to the Actions tab, and I'm going to click on Rolling Update. I've set the min seconds ready here to 10. This is just to kind of slow things down so we can talk through it. And I'm going to go ahead and update the image tag to version 2.0. And so when I click Update, what's going to happen is it's going to declare that I now want 3 of the pods running with version 2.0. And we'll see actually that it's going to bring up a new version 2.0 pod, and then it's going to shut down a 1.0 pod, and then it's going to bring up another 2.0 and shut down. And so eventually we'll have 3 of the 2.0 pods and 0 of the 1.0 pods, but it's going to roll those updates. So actually we can see here we had those 3 running, we have 2 creating of the new version, and again up here we see 2 and 2 as it's starting to shut down one of those. Let's hit refresh and see the next state. So we still have some pending. We actually have 3 of the new ones and 1 still shutting down, it looks like. All right, so now we've got the green checkbox again. We have version 2.0. We have 3 of them running, and we can, if we wanted to, go and look at the logs again. So we have just shown troubleshooting and debugging in the UI. Then we actually made some changes to resolve the problems. Then we scaled it up, and then we rolled out an update. So can we switch back to the slides? I'm going to hand it back to Matt for the 3rd demo.
Sure. Thank you, Ian. All right, so the last thing we're going to show you today is how you can deploy an application from the marketplace to any one of these connected clusters. So the first thing we're going to do is we're going to quickly choose a cluster. Then we'll have an application that we choose and configure. And then we'll just go ahead and deploy it. And I'll show you, it's actually quite easy and quick to get started with this. So if we could switch back to the demo, that would be great. Can we switch to the computer? Thank you. All right, so the first thing you'll notice is if we look at the Kubernetes Engine tab, there's a Marketplace button. I think this actually shows up in pretty much any page now. But if you click on Marketplace, you'll see that there's a whole bunch of Kubernetes app solutions. One of the ones that I'm just going to show today is just a basic Nginx instance. So if we search for Nginx, you'll see that we get a list of solutions. If we narrow it down to just Kubernetes apps, we're presented with this result. If we click on that, we'll get a little bit more information about the solution. You can read more about pricing, and this one happens to be free. You can learn more about click to deploy containers and the applications themselves. Now we want to deploy this one, so let's go ahead and hit configure. And it'll bring us to a new screen where I've got a lot of information here so that will allow me to configure it. So I can select amongst any of those 4 clusters. Since I registered that COPS cluster running on AWS, let's go ahead and deploy it there. I can choose what namespace to deploy it to, as well as a number of replicas. Let's just choose 1 to make it a little bit faster. If I hit deploy now, it'll actually use that connection we've created between your cluster and Google. And it will use the credentials that I just logged in with and to actually deploy this application. It turns out it'll take a few minutes to deploy, but if we go over to the workloads screen, actually the application screen, you'll see that I actually previously deployed a WordPress instance on that same COPS and AWS cluster. If I go to the Services tab, you can see that we've actually exposed the Nginx ingress that comes with the AWS cluster. And if I click on this, it'll actually bring me to the running instance of that WordPress app. And so what we've done is we've integrated with the information that we get out of the Kubernetes objects to actually show you the endpoints running in other clouds as well. So the really cool part about this, just to summarize, if we go back to the slides for a second, is that we were able to, with a few clicks, actually deploy an application from the marketplace. You saw that demo took less than 2 minutes, I think, and we actually got something that's up and running, which is pretty awesome. And so just to summarize, today we discussed how agility and velocity, along with running anywhere, is top of mind. We briefly discussed how Anthos is uniquely positioned to help you meet your goals. And we showed you a feature of Anthos that helps you get visibility into your workloads that are running anywhere. With it, you can quickly and easily connect clusters to GCP, interact with and debug workloads through the UI, and even deploy applications to connected clusters with just a few clicks. We also mentioned that connecting any Kubernetes clusters has just entered alpha. And if you'd like to learn more or participate in this alpha, please contact your sales representative to express interest.